welcome to Chemistry at Hananiga High School. Today we'll be looking at our second set of notes in this chapter, which is dealing with binary molecular compounds. So the nomenclature of binary molecular compounds, which really just means finding their names and formulas. Now, what I want to start off with is really what I finished up with in the last set. We talked about elemental substances and the fact that there are 7 diatomic elemental substances. Remember, that's only when they're elemental. When they're in a compound, we ignore completely diatomic. Hydrogen is just H atoms when we're looking at a molecule. So don't get diatomic prefix too happy and start sticking twos every time you see one of the 7 diatomics. Remember, that's only in their elemental form. Now, one of the nice things about molecules is they're fairly straightforward in terms of a formula. If you look at the formula substance and it's all nonmetals, remember that's hydrogen plus everything to the right of the stairs, it's going to be a molecular substance. So every single one of these substances, no matter how simple or complex, it's all nonmetals. So all of these would be molecular in nature. Now, most molecular substances are compounds, but remember we have the diatomic 7 molecular elemental substances. Well, we've already talked about those. So what we're really looking at here is when we have a compound. So every single one of those had nonmetals and they were molecular. So when you have a compound of just 2 nonmetals, we're going to have what's called a binary molecular compound, because binary literally means 2. So 2 element molecules are the only types of molecules we're going to look at naming. So we're only dealing with simpler type molecules. Now, we use prefixes when we're dealing with molecules to literally say how many atoms of that element we have. Unlike ionic compounds, where we can look at the charges to figure out what the formula is and therefore how many there are in the molecule, or I'm sorry, in the unit, you can't do that with molecular things. There are more complex situations. So hydrogen, there could be 1 or 2 or 3 or 4 of them in there, depending on what it happens to be with. So we have to just flat out say how many atoms of the elements are there using prefixes. Now, if you take a look at the prefixes we're going to use, most of these you're already familiar with. So from math class, when you got into geometric shapes and you talked about pentagons and hectagons and so forth, you've actually seen a number of these, or you've seen that prefix used in a word in everyday life, like triangle. You know, tri means 3 then, or a monocle. Mono means 1. So these are how we identify how many atoms of a given element are in the compound. So you do need to become familiar with them. But remember, most of these you already know. You just need to look at the ones you don't know and come up with a way to remember them. Like number 4 is tetra. If you have 4 atoms of something, then it's tetra. Well, how do you remember tetra? Well, think of the game Tetris. The reason it's called that is because the blocks that fall, all of them are formed from 4 blocks put together. So hence the name Tetris. Or pentagon, you know, the pentagon is a 5-sided building. Octagon, you know, that's 8. A decade is 10 years. So really most of these you're going to be familiar with. The 2 that I think people are the least familiar with are hepta and nona, the 7 and the 9. But I would bet you've seen those in math class as well. So when you go to do a binary molecular compound name, the first thing you're going to do is you're going to name the first elements using a prefix to say how many you've got. So literally you take the element name and you put a prefix on it to describe how many you have. Now the one rule that's a little bit different with the first element is we never use the prefix mono when there's only 1 on the first one. So if there's 1 carbon, we just say carbon. We don't say monocarbon. But this really only applies when we're talking about the first element. So in N2O4, 2 nonmetals, this is a binary molecular compound. We have 2 nitrogens, so it's dinitrogen. And that's literally how we describe that it's N2. Now, if we had something that should be mono, remember, we don't write the mono on the first one. So CO2, you know, is carbon dioxide. Well, we don't say monocarbon dioxide, it's just carbon dioxide. So that's the one special thing to remember about the first element. Don't use mono if there's 1. It's understood that there's just 1. But on the second element, you always use the prefix. And then we change the ending in a way that we did before. Remember the nonmetals as ions? We changed them to "ide," so oxygen became oxide and chlorine became chloride. Well, we do the same exact thing with our second nonmetal in the binary compound. So we use a prefix to describe how many, and we change its ending to "ide." So carbon dioxide, you've heard that before, you know that one. So in the case of N2O4, that second element, the four O's, that would be tetraoxide. Now, one of the things that I'm not going to worry about all that much is the spelling exactly perfect? Because sometimes when we put on these prefixes or put on the suffixes at the end, you end up with odd situations with like a double vowel, and it seems like sometimes they leave it and sometimes they get rid of one of the vowels. That's okay, as long as I see clearly it's try, and as long as you're clearly showing me the second one was the iodine element and you called it iodide. Even if you end up spelling it slightly wrong, you're still going to get full credit for it. So remember, it just needs to be the appropriate prefix, and you need to change the ending to an "ide." And even if you don't do it perfect, as long as you've done those two things, I'll give you credit for it. So that's how we name molecules. So in the case of CO2, it was carbon dioxide. In the case of CO, it's going to be carbon monoxide, another common molecular substance that you've heard of before because it's very dangerous. So all we do is use prefix. That's basically it. So molecules are a whole lot easier than ionic compounds. You just have to know the prefixes. So Br2O7, well, that's two Brs. Two is di, so we would call it dibromine. And then 7 is hepta, and oxygen becomes oxide if it's the second element. So we've got dibromine heptoxide. And you'll notice we drop the A in the hepta. If you don't, no big deal. As long as you've got the hept, and as long as you've got oxygen as oxide, you're perfectly fine. And then the second one, Si and O, well, we don't say mono on the first one, so that's just going to be silicon. But we do have to say the mono on the second one, and that becomes monoxide. So silicon monoxide. And you'll notice in this case, we drop the O in mono. Otherwise, it would be like monoxide, and that doesn't make any sense. But if you did write it as a double O, that's fine. I'd still give you credit, as long as you had the oxide and the mono. Now, in the opposite direction, it's even easier. All you're literally doing is translating how many you've got. So triphosphorus, that's P3, pentoxide, that's O5, and you're done. So these are really quick when you're taking the name of a binary molecular compound and writing its formula. And then tetrachlorine nonafluoride, tetra is 4, so we have Cl4, nana is 9, so we have F9. So Cl4, F9. So if that substance actually existed, that's what it would be called. But that's one I purely made up to practice the idea here and see some of the other prefixes. So in today's homework, what you're going to be doing is you're going to be looking at finding the names and formulas of molecules. But mixed in with them, you're also going to have elemental substances like we did the day before. So remember, first thing you need to do is think element or compound. And if you know it's an element, then we're just doing what we talked about with our first set of notes. Name is the name, and then the formula, don't forget the diatomic 7, they need a 2 as a subscript. But if it's a compound, if it's more than one element, then we're going to use what we looked at today. And that ends our second set of notes.